My name is Aliana Yu, and today I'm going to talk about my research topic, 2 games and graphs extended from the game of Squayles. First, let's talk about the game of Squayles. It is a 2-player game. At the beginning of the game, 31 sticks are arranged as in the figure below. The 2 players take turns making moves. In each move, a player removes as many but at least 1 sticks as they want, providing that the head of any stick is adjacent to the tail of the previous one in sequence. Below are some examples on legal and illegal moves, where the sticks marked red are the ones removed. First, the moves these 2 figures represent are legal because you can remove the red sticks in the order labeled on each stick, which satisfies this rule. On the other hand, these 2 figures represent illegal moves. For example, in this figure, there is no way to remove these free sticks so that this rule is satisfied, and thus this move is illegal, and so is this one. The 2 players take turns removing sticks like this until all the sticks are removed. When this happens, the player who removes the last stick wins. I generalized the game of Squayles into a game called the trail removing game, which is played on any given graph G. In the trail removing game, the 2 players take turns removing the edges of a trail, which means a walk without repeating edges of at least one edge from the graph G. So they keep removing edges like this until there are no more edges left to remove. When this happens, the player who removes the last edge wins. I also created another game called the star removing game. The rules of the star removing game are the same as those of the trail removing game, except that in the star removing game, the players take turns removing the edges of a star subgraph instead of the edges of a trail. The purpose of this research is to solve these 2 games on certain special graphs. Now here are my results. For the trail removing game, I first determined the winning player on some special graphs. Next, I defined a new kind of graphs, known as nice graphs, and solved the game on all nice graphs. Finally, I get some results regarding the joint product and the Cartesian product of 2 graphs. As for the star removing game, I first determined the winning player on some special graphs as well. Next, I introduced a concept known as symmetry by defining these 3 kinds of graphs. I then determined the winning player on these graphs and gave certain properties regarding them. With these results, I solved the star removing game on r-dimensional grids in general. Here are my results on special graphs summarized in this table below. Here are my more generalized results. This is the end of my report. Thank you very much!